Artificial intelligence and machine learning. We are starting with a brief recap. Big data is both the data themselves and tools for their storage and processing. In turn, big data is a kind of a fuel for artificial intelligence, which includes machine learning and deep learning. We can say that artificial intelligence consists of four major fields: data science, computer vision, natural language processing, and machine hearing. And all of these areas can be applied to agriculture. These three major forces are driving machine learning and deep learning as well. Equipment, for example, CPU, GPU, and TPU. TPU stands for Tensor Processing Unit. Second one, datasets. It's a big data. And third one is algorithmic achievements. Machine learning is called a sub-area of artificial intelligence. Its goal is to, based on an existing dataset, it's called a training set, with the highest possible accuracy to find a function to predict the outcomes of a subset of previously unobservable data. It's test set. Alright, we have training data. For example, it can be questions and answers, labeled data, and we try to map these questions with appropriate answers. So we build predictive model using some machine learning algorithm. Then we have new data and use our trained model to process this data in order to solve the task we have. For example, to build the forecast. Machine learning is divided into supervised, unsupervised, and reinforcement learning. The training data consists of a set of training examples. In supervised learning, each example is a pair consisting of an input object and a desired output value. Supervised learning algorithms analyze the training data and produces an inferred function which can be used for mapping new examples. An optimal scenario will allow for the algorithm to correctly determine the class label for unseen instances. This requires the learning algorithm to generalize from the training data to unseen situations in a reasonable way. So, for example, for supervised machine learning, we can say it's classification, task, regression, and ranking. For unsupervised, it's clustering, dimension reduction, association rules, outlier filtering, for example. And the problem of unsupervised learning is that of trying to find hidden structure in labeled data. Reinforcement learning refers to goal-oriented algorithms, which learn how to attain a complex objective or goal, or maximize along with a particular dimension over many steps. For example, maximize the points won in a game over many moves. And there are other types of machine learning approaches. It's partial learning, self-controlled learning, transductive, dynamic, active, meta-learning, etc. This is an example of classification task. We are dividing our datasets into several classes. Here is the regression task, where we try to predict a number. Another example, if you want to compare classification and regression tasks, then in the case of student, we have a student profile. We use classifier to find out if the student will pass the exam or not. From the other side, we can use regression model to predict their mark. Here is an example of clustering task. This is unsupervised learning. In this case, we have unlabeled data and we ask the algorithm to cluster the data, that is, to split them into several groups with elements in the same group being similar to each other and the elements in different clusters are significantly different. Reinforcement training can be compared with trial and error methods. This example shows how the algorithm learns to win a computer game. The algorithm tries to maximize the point won in a game over many moves. They can start from a blank state, and under the right conditions they achieve superhuman performance. Like a child incentivized by spanking and candy, these algorithms are penalized when they make the wrong decisions and rewarded when they make the right ones. This is reinforcement, and this is reinforcement learning. This example shows how algorithm or virtual man tries to learn how to jump over the wall. Several years ago, reinforcement learning approach helped to win the world champion in Go game. The most popular approaches in machine learning are linear models, random forest, gradient boosting, and neural networks. And neural networks play a special role here. Neural network is a series of algorithms that endeavors to recognize underlying relationship in a set of data through a process that mimics the way the human brain operates. Neural networks can adapt to a changing input, so the network generates the best possible result without needing to redesign the output criteria. And deep learning includes multi-layer neural networks. The deep learning method is to combine simple layers that implement some form of step-by-step data cleansing. And the model of deep learning can be compared with a sieve consisting of a sequence of filters of more and more fine data cleaning or layers. In computer vision problems, we often deal with convolutional neural networks. It can be used in object detection tasks. For example, this is an example of cow face detection system. It allows farmers to better monitor their nutrition and increase milk yield. Scanners determine how much food and water each cow consumes. It can be used in self-driving vehicles, particularly in autonomous tractors. And convolutional neural networks has two interesting properties. The patterns learned are translation invariant. After recognizing the pattern in a picture, it can recognize anywhere. They need fewer training images to learn representations. And the second one is spatial hierarchies of patterns are learned. And the first convolution layer, for example, will learn small local patterns, such as edges, and the second layer will learn patterns made by features of the first layers, etc. Thank you.